Good morning everyone. So let us today understand about the fourth program, that is build an artificial neural network by implementing the Bragg propagation algorithm, and we are going to test the same using some data sets, so predefined data sets according to what the error we are predicting. So here the error we are predicting is based on the minimum error what we already studied in the module number 3. So let us have a revision back with some video clip so that you can have a quick understanding about what actually does the back propagation algorithm do. Okay, right.
Hi, welcome to another video of Code Wrestling, and in this video we are going to talk about one of the most important algorithm, that is backpropagation algorithm. So what is backpropagation? Backpropagation is a supervised learning algorithm that is used to train neural networks. Now you can see one diagram on your screen. Yeah, that is a neural network. It consists of an input layer, a hidden layer and an output layer, and each layer consists of neurons. So you can say that a neural network is a circuit of neurons. Now, why we need to learn backpropagation? So if I have to design a neural network like this, then in the beginning I have to initialize all these weights with some random values. Now I am not a superhuman, so there is a least probability that whatever weight or values I have assigned will lead to the correct output which I need. Okay, fine. So we have initialized some weights. Now our model is way different than our actual output, and thus the error value is high. So what we need to do? We need to somehow change these parameters such that error becomes minimum. And how we are going to do it? So let's introduce gradient descent. Gradient descent method is used to update the weight by reducing the error function. So let's say at initially if you were at this stage, that is the error was in this stage, then you will perform gradient descent, that is basically differentiation of this function, and the slope will give you the direction where you have to go, whether you have to move upward to reduce the error or you have to go downward to reduce the error. So thus the gradient descent method helps to update the weight while also maintaining a minimum error function. So now let's understand the complete overview of backpropagation. So you have a model we have a model that we will initialize with some random values. Then at the first stage we will calculate the error, that is forward pass, and then we will calculate the error, actual output minus the predicted output. Then we will see whether the error is minimum or not. If it is minimum, then the model is ready to make prediction. If it is not, then we have to update the parent method, and then again we will calculate the error, again we will check whether the error is minimum or not, and this whole process is known as training the model. Now let's understand backpropagation with a very simple example. So here we are designing a neural network which has 2 input neurons, 2 hidden neurons and 2 output neurons. Additionally, we are using 2 more things, that is known as bias, whose value is 1, which doesn't have any incoming node, but all it has is an outgoing node. Now a very important question arises, that why we are using bias when it doesn't have any incoming node, and it is important to address it. So if I consider a very simple neural network that has only one input and one output, then obviously the output of this neural network will be W1 into X. Now if I plot a graph, then it will look like this, that is a straight line which always passes through origin. But what about the y-intercept? In always it will give the line which passes through origin, but there is some possibility when we have to deal with y-intercept too. We have to use the output of bias, which is represented as W underscore B, whose value is 1 into B1, where B1 is the weight of the bias. So this is what the main purpose of bias is. Now let's not get too much attached with it and should move on to our example. If you need more details about it, then you can find the link in the description to learn more. Now this is the neural network which we were talking about. Now all the values has been initialized from I1 to I2 and from weight W1 to W8, and also the bias B1 and B2, and also the actual output which we need, that is 0.01 and 0.99. Here the first step is forward pass, that is we will go from I1 to O1, that is calculating our prediction output by taking all these initialized or random values Then we will calculate the error, that is the actual output minus the predicted output, and then we will move all the way back from O1 to I1 and update each values of this weights by using gradient descent method such that the error should be minimum. Again we will go forward pass, calculate the prediction output, then we will calculate the error, again we will move backward and while updating all the weights, and the whole process will continue till the error is minimum. So let's see the first step, that is the forward pass. So what we need to do, we have to move from I1 to O1. So first of all we have to calculate the value of H1, that is net H1. So net H1 can be calculated by seeing these lines. You can see from H1 there is one line from I1 and one line from I2. So net H1 value and one line from B1. So net H1 value will be I1 into W1 plus I2 into W2 plus 1 into B1. That is what written over here. Now substitute all the values and you will get the value of net H1. Similarly, you have to calculate the value of net H2. So net H2 will be I1 into W3 plus I2 into W4 plus 1 into B1. That will be the value of net H2. But this net H1 and net H2 is not enough. You have to squash this function. That is, you have to put the values between 0 to 1. Thus, for that, you have to use this formula. Out H1 is equals to 1 upon 1 plus e to the power minus net H1. So whatever net H1 you have calculated over here, just substitute its value and you will get the final answer of out H1, and same you have to do for out H2. Now since we have reached till H1 and H2, now we have to move on to O1 and O2. So for O1 and O2 we have to follow the same procedure. For O1 it will be H1 into W5 plus H2 into W6 plus 1 into B2, and similarly for O2 it will be H1 into W7, H2 into W8 and 1 into B2. As we have calculated net O1 or net O2, now we will calculate out O1 and out O2. So out O1 formula will be again the same thing, 1 upon 1 plus e to the power minus net O1. Substitute this value and then you will get the output value. Similarly you have to perform this operation for out O2. Now you can see our output value of first node is 0.75, but what we need is 0.01, and for second the output value is 0.772, but what we need is 0.99. So obviously there is a huge error. So what you have to do, you have to now calculate error. So how to calculate an error? Error is defined as summation of half of target minus output. Here this target is the actual value and this output is the predicted output or the output which we were getting. So if I will calculate for O1, then half of what was the actual output, that is 0.01, and what output I am getting, that is 0.75. So this was the error for O1, and similarly I will calculate error for O2, and the total error will be EO1 plus EO2. So this is my total final error. Now what we have to do, we have calculated the error, now we have to update the weight such that this error value should reduce. So we will go backward path, that is we will move all the way from O1 to I1 and we will update each values such that our error should be minimum. So from here on I will suggest you to follow up with me, write it down so that you can understand the things thoroughly. So first of all we will consider the weight W5. Now we have to calculate the partial derivative of total error with respect to W5, that is you have to partially differentiate it, but you cannot directly differentiate it, you need to find some relation between this total error and W5. So you have seen a lot of formulas before where E total is dependent on out O1 and this out O1 is dependent on net O1 and finally net O1 is dependent on W5. Diagrammatically it will look something like that, that the total error is now dependent on out O1 on net O1 and finally net O1 on W5. So we can write the formula directly over here. If you know homogeneous differentiation well, then you can understand it very clearly. So total error, partial derivative of total error with respect to out O1, then out O1 with respect to net O1 and finally net O1 with respect to W5. So this is what the formula which we have of total error with respect to W5 by using this. Now you have seen the first two terms. Yeah, the multiplication of this two term is also known as delta rule or delta function. That is the total error, partial derivative of total error with respect to net O1. This is just the term which you might have heard before or something like that. So now just moving on, we will calculate that our partial derivative of total error with respect to W5. We have got the formula. Now we have to calculate the first term. So we know what is E total. E total is defined as this. Now we have to differentiate it. So this particular last term, that is the second term, will be treated as a constant, and the differentiation of this will be 0, and differentiation of the first term will be 2 into 1 by 2, target of O1 minus out O1 to the power 2 minus 1. Substitute all the values, you will get the value for partial derivative of total error with respect to out O1. So we have calculated the first term. Now we have to calculate the second term, that is partial derivative of out O1 with respect to net O1. So we know what is out O1? Out O1 is 1 upon 1 plus e to the power minus net O1. So if you will differentiate it, partially differentiate it with respect to net O1, then this is what the value we will get. If you have any confusion with the differentiation, then look at this term 1 upon 1 plus e to the power minus x. I am just replacing net O1 with x. Now if you will transform it, then e to the power minus x can be written as 1 upon e to the power x, and if you will further transform it, then it will become e to the power x upon 1 plus e to the power x. Now it looks easy to differentiate it, so its differentiation will be e to the power x upon 1 plus e to the power x whole square. Now if you will split it into two terms, that is e to the power x upon 1 plus ex multiply by 1 upon 1 plus e to the power x, then this term will be considered as f of x. You can match it, and the other term will be considered as 1 minus f of x. So like that we got the partial derivative of out O1 with respect to net O1. Now substitute the values and you will get the final answer for out O1 with respect to net O1. Now we have calculated first two terms, the last term is remaining, net O1 with respect to W5. So when we will calculate it, you know the formula of net O1. When we will differentiate it with respect to W5, then the last two term will be considered as constant and its differentiation will be 0, and finally we will get the answer as 0.5932. Now we have calculated all the three values, substitute it, and you will get the final total error with respect to W5. But still we have just got the total error with respect to W5. We have to now update the weight. So to update the weight, we have a formula that the final updated weight is equals to initial weight minus eta into total error with respect to W5. It is also known as gradient of W5. So what is eta over here? Eta is defined as the learning rate, which actually tells that how far you have to go, or what is the rate you want to increase your weight or decrease your weight, something like that. So here what was the initial weight? Initial weight was 0.4. Here the value of eta I am considering as 0.5, and the total error which we have got, I have substituted the value over here, and this is what the final weight, the updated weight which we have got. Similarly, we will perform the operation for W6, W7 and W8, and we will get the final updated weight over here. Now since we have moved from O1 to H1, but we have not moved till I1, we are still here at the intermediate stage. So we will perform the actual updates in this weights only when we have reached till I1. What I mean to say over here is, let's say if I have to move from H1 to I1, and let's say if I have to use W5 in between, so I will use the initial weight, not this updated weight. Are you getting what I mean? I'm telling that if I have to use W5 at this stage, then I will not use the updated weight W5, but I will use the initial weight which I have used. Okay. So now we have to move from H1 to I1. So again we have to calculate, first of all I am considering W1. So we have to calculate the partial derivative of total error with respect to W1, and it will be equals to E total divided by out H1. You can see how it is dependent, E01 on out H1 on net H1, and then net H1 on W1. But still there is a confusion with E total by out H1, how it is related. So you can see E total by out H1 can be written as E01 plus E02, and you know E01 is dependent on out O1 is dependent on net O1, and this time net O1 is dependent on out H1. We will not see W5, but we will see out H1. Why? Because we need out H1. We need to find relation between total error and out H1. So now if you will see the value of this first term, that is E01 by out H1, so it will look something like that, E01 by out O1 multiply by out O1 by net O1 multiply by net O1 by out H1. So these two terms which we have already calculated before. The last term, the differentiation of net O1 with respect to out H1 will be equals to W5. See this value, if you will differentiate this with respect to out H1, then only W5 will be there. These two terms will be treated as constant and the differentiation will be 0. So we have got the values for these two terms, substitute it, you will get the final answer. Similarly, we will calculate for E02 with respect to out H1 in the same way. Now add both the terms, so you will get the total error with respect to out H1. But still we have just calculated the first term, we have to still calculate other two terms. So you know what is the formula of out h1? Out h1 is 1 upon 1 plus e to the power minus net h1. If you will differentiate it, then this is what the value you will get. Similarly for net h1 is w1 into i1 plus w3 into i2 plus b1 into 1. If you will partially differentiate it with respect to w1, then this two term constant, it will become 0 and the final answer will be i1, that is 0.05. So now you have got value of all these three terms, substitute it and we will get the total error with respect to w1. Now again we have to update the weight w1. So w1 is equals to w1 minus eta into total error with respect to w1. Now substitute all the values. As I have said, eta is the learning rate and the value is 0.5. Substitute the values and you will get the final updated weight of w1. Repeat this procedure same for w2, w3 and w4. Now finally we have updated all our weights. When we feed forward the 0.05 and 0.1 inputs, originally the error on the networks was 0.298371109, and after the first round of back propagation the total is now down to 29102. So yeah, there is a little change. What I mean to say here is, at the initial stage we have this error. Now when we have updated the weight, after that we have got this much error. So there is a little reduction. If we will perform it for 10,000 times, then after that the error will be reduced to 0.000035. So this is how the back propagation helps. This is the entire process of back propagation. Hope you have understood the video. Stay tuned with us. Do like, subscribe, share and comment. You can
This was the brief introduction for the back propagation algorithm, what we already learned in the module number 3. So just look out at the code. Okay, so here we are taking the two things like x and y. Okay, so we are going to define the same things like what we did for applying the gradient value, that is for calculating the net value for net h1 and net h2, that what we understood in the example in the video clip. So it is like 1 divided by 1 plus e raised to minus x, something like that. Okay, same thing is been applied as so here we are taking epoch value as 1000, so we are going for 1000 iterations, so that we are going to train our model very efficiently. Okay, so here eta is been taken as 0.2, number of input neurons will be 2, okay, hidden neurons will be 3 and the output neurons will be 1, so that we are going to get the result accurately. We are taking very less number of input neurons, hidden neurons and output neurons, so as because we need to confine it very accurately. Okay, we need to get it accurately. So we are taking random inputs at the starting. We are taking random inputs at the starting for all the input neurons as well as the hidden neurons and the output neurons. So at the starting we are not going to have a value which is been set. So the result what we are expecting, let me show you the result. 1 second guys. So the predicted output what we are expecting is with the values like 0.89, 0.87 and 0.894. So with this will be the predicted output what we are expecting for different output values for the different neural networks for hidden neurons as well as for the input neurons. So input neurons will be what will be taken as the input. So what will be the output will be provided from the respective hidden layers, that is h1, h2 and h3, that outputs we are going to get here, so that is what the predicted output we are trying to get it. So based on that we are taking the random values here, so it will be taken in the form of the number of epoch values. So 1000 epochs we are taking, so the 1000 epochs will tell us that it is going to repeat the number of iterations for 1000 number of times, 1000 number of times. So this will be in the for loop, so we are going to apply all the formulas what we just did check in our video. So first we will go for forward feed forward from I1 to the O1, in between the hidden layers will be there. So now here we have two input neurons and three hidden neurons, and what is that, three hidden layers, and then only one output neuron. So here we have I1, I2, and hidden layers like H1, H2 and H3, and output as only O1. Okay, so first we will go from input neurons to the hidden neurons, and then from hidden neurons to the output neurons. So if that does match with the erroneous conditions, which is actually least value as according to what we predicted, so if it is the case, then we will not go for the back propagation algorithm. So if the erroneous state what is not as that what we predicted, so again we will go for back propagation, like again we will go from the output to the hidden layer, then hidden layer to the input layer, and so that we will repeat this as like a training the data, as like a training a data, so that we will get the less erroneous. So this is what how your backend back propagation algorithm will work for the artificial neural network. Okay, so I hope you have already used this back propagation algorithm with some respective projects previously, what we did saw the presentations on the day. Okay, so there also one couple of projects, they have used the back propagation algorithm to train their data sets. So this is how the training will keep on going. Okay, so as number of epochs you will take, so nicely the training will be done. Okay, so nicely the training will be done, and it will depend on the number of inputs and number of the output. Okay, number of input and the number of output. So this is the very simple thing need to be understand. There is no any complicated thing is there available here. Okay, so finally we are going to get the normalized input. Normalized input means what? After having the erroneous conditions which is minimized one. Okay, then actual output what we got at the previous stage, and the predicted output what we were predicting for. Okay, right, so that you can find out the values here. So normalized output was 0.66, 0.33 and 0.55. Okay, so it will be regarding with the three different layers. So actual output what we were intending for is 0.92, 0.86 and 0.89. so predicted output was 0.89, 0.87 and 0.94. okay, so it depends. So but actually once we see they are all near outputs to one another. So actual output was 1.92 for the H1, so it is what it is coming as a 0.89, which is again a nearer output. So second layer output what we are expecting is 0.86, and it is coming 0.879, so it is also nearer output. So third one was 0.89 and we are getting 0.89 as it is. So this is how we can predict, like we are getting the correct output. So let us run this program. So how to run this program? Go to the run button and press run. So here this is a lab 4 what we were executing, and click here lab 4, so you will get the output. Fine. Okay, so actually this is what the output we got it from the program what I executed previously. So let us go back and check out how do we can execute this. Now previously we did lab 1, lab 2 and lab 3. Today we will do for the lab 4 execution. So go for a new, so here you choose the Python file, so give the name of the Python file as lab 4. No need to worry about the extension, as because since I am creating a new file as a Python file, so .py extension will be taken as automatically. So press enter. Okay, so I will get the lab 4 file. So here I need to write the program. So for now just copy and paste the program what I sent you in your Google Classroom. So Control C is the copy keyword. Okay, and I'm going to paste here by pressing Control V. Okay, so quickly immediately go for the run button and just press run. So this will ask for which file to be run. Go for the lab number 4. So here you will get the output, respective output. Okay, so every time once you see the predicted output will changes, but see that the predicted output will be same as that of what we were expecting, what was the actual output we were expecting. Okay, right then, so this is regarding the lab number 4. If you have any more doubts, you can ask me, come to me personally, and you can ask me personally. So now for as please do check the videos what were being kept for you for understanding. So suppose if you did not understand, please go back to this video what we learned for your backpropagation neural network algorithm. Okay, and then please do revise it back and try to correlate with your code. You will definitely understand what we are doing here. Okay, right, so we will sign off now. Thank you guys for attending this lab number 4. Thank you.